Hi, for today's teardown, in this bright orange transit case, something I wanted to have for a very long time. They are very expensive and hard to find, almost impossible to find at a reasonable price. We have here a Pentax PTS 205. So what is a PTS? By the way, it stands for Pentax Total Station, not to be confused with a total station. So actually it is something everybody have already seen being used onto a construction site or onto the side of a road. Quite a common device to see, not to own. So before you open the case, instructions here about the latches, which are quite secured and strong, and a tag from the previous owner in Italy. It is actually a very old company, Guido Veronesi in Bologna, Italy. Okay. So, what do we have in here? Are you ready for the big reveal? Ta-da! Yes, one of those things you see quite often being used on the side of the road. So I will pull it out of the box. You can see a very serious transit case with still original dust cover, never used, and even an original cloth to clean the device. Interesting. Some instructions here, but it is not the main area of interest. Of course, you want to see this. I made a little bit of a custom stand for it. Here we are. So this device it is a evolution of what are called theodolites. It does very precise measurements of angles in horizontal and vertical axis, and also very precise distance measurements. You compute all this, so you aim it at a special prism reflector target. And it will allow to calculate areas of a piece of land, also volumes of buildings, relative positions of particular points, and things like this. So you can notice it turns freely and endlessly on this angle, and also quite weirdly on this angle. You have one control panel at the front and one control panel at the back, which is quite weird. And weird stuff everywhere. So on the top I am missing actually the battery that comes as an extra layer of this handle and looks like this. I am missing also at the bottom the adapter to the tripod you will mount it on, or tri-brack it is called. This part alone is worth around 100 euros used on eBay. So it is why I was not given it, because this is a defective unit. I got it for 50 euros. It is a good price because the working ones are between 500 and 1000 euros for this generation, and the newer models can be, by Leica for example, can be up to 20,000 euros. Quite insane pieces of equipment. By the way, the newer ones are automated and robotic and do things automatically for you. You can even calculate the volume of a pile of sand with newer devices with laser scanning and things like this. But this one is old school. So I think the best thing we can do first is to have a look at some pages from the user manual for the name of the parts and the specifications. So the user manual is easy to find on the web. We will have a look at the parts names. As I said, I am missing the battery here on the top, which is locked to the top handle. It has its fuse holder. We have, of course, our main objective lens for sighting and telemetry. We have a little bit of a collimator here. Instrument center mark, so it is the axis of this part here. We have optical plummet. In fact, it is an optical system that looks downwards to the middle of your tripod to align it properly. So a whole optical system here looking downwards. We have your keyboard and your display panel. We have the lower tangent screw and the lower clamp screw that will secure on the vertical axis the movement. I am missing here this part which has a vial and leveling screws for the tripod. It is actually called a tri-brack. Bottom plate missing also. Other side. So the battery apparently has a power switch and a charging connector. I did search eBay for a used battery, but even this is super hard to find. There was a grab bag of various batteries, but not for this particular one. You have your eyepiece with a focusing button, and just this eyepiece seems to be super complicated. Reticle illumination switch to illuminate the reticle inside here. This part is apparently called the telescope, and you have a locking screw and a setting screw also. Switch cover to deep switches for settings. Your over display panel. So here I do not get really why you have also a tangent screw. So you have an upper and lower tangent screw. They seem to be doing the same thing. Quite weird. A plate vial here to check horizontality of the device. About the specifications. The image is of erecting kind, 32 times magnifications, focus at 1.4 meters. The measuring range, apparently up to 2,600 meters, according to the conditions and the version of the device. Here are your atmospheric conditions. Accuracy of 5 millimeters. No, even here 1 millimeter in fine mode. Interesting, because you have a maximum slope distance here way higher than your measuring distances. And apparently, from what I did read, the distance measuring is very sensitive to temperature for some reason, and need to be compensated. So we might have a temperature sensor, in fact, inside this device. Your angle measurements by your rotary encoders, of course, very nice devices. Then display and other specifications. About the accessories, you can have a whole bunch of extra electrical parts to power in a car and things like this. You have a data collector device, you have your tripods, metal or wood, optional eyepieces, and here are your targets with a glass prism apparently onto a monopod or a tripod also. So it is what you aim at to do your measurements. Okay. So first power on demonstration for you and why it was just 50 euros on eBay. This device is defective. It gives an error code 06 after the sales check. There we are. And I did not find any useful information about this error code. I found actually a number of loose connections in the device for some reason, but it did not help. Okay, now a closer look at the parts. So the top handle here, I believe, has a structural integrity purpose and will be necessary for the device. And also when you remove it, it gives access to the mounting panels that will allow to remove this wall part, which I will probably not do because of the rotary encoders and the rotary contacts. So your eyepiece here with a little cover we will open later. This setting will actually move super slowly the telescope piece. You can see it is super slow. We have a locking button here, but even when it is locked, you can still move it in one direction like this, which is quite weird. And I believe it is the same with the other one, but I have a broken part here, so I cannot really test this. Now I will start by showing you the bottom side here. So it is where we have probably our rotary contacts for the auxiliary connectors here, and we have the optical plummet, which actually is optically connected to the eyepiece here on the side. You can see. Okay, I will remove this little cover for you to show you what we have behind it. I guess it is rotary contacts. Will it collaborate? Yes, and as expected, very shiny golden rotary contacts. You can see, which I will not disturb, because anyways the centerpiece here, it seems everything is soldered and goes in the center axis. I will not also undo the other screws here because it should be quite catastrophic, I believe, if I do this. Okay, so that's the time to reinstall this cover, and I believe we will have a look at the control panel. So I will undo the control panel on this side. The other one is exactly the same, except we do not have a mechanism here. So it is not worth undoing the other side. But at least we'll be able to see what is going on. I have no idea of what are doing the buttons, except maybe the light bulb button, but the other ones quite mysterious. But you can check the user manual if you want. I will link it in the video description. So we have two very flimsy connectors here to this board with Hitachi chips for the LCD probably. So nothing particular here. And we have this mechanism for the precise, so the tangent screw, it is called. tangent button. This housing here is probably your rotary encoder housing. And we have this system. On the side here there is this cap I can turn with long nose pliers, and it will undo this wall assembly. With actually a spring loaded piston like this that will push in here. And on the other side we have, I will reinstall it before it gets too messy, just a little bit like this. On the other side, if I remove the remaining set screw, it will pop out because of the spring, and we have this very nice brass part with transmission parts here that will go into a matching piece in here and rotate something deep inside, but I will not be able to take it apart any further, I believe, but you can get the idea. It seems to be a field repair part, because obviously my button here is broken, so you need to be able to replace the part, not field repair but workshop repair I mean, on the common replacement part, so quite interesting. Okay, and we have exactly the same system at this level for the other axis. You can see the same thing. Okay, I will put this back together and we will open the side here with the rotary encoder. So this cover should come off. Okay, here is what we have. A circuit board with probably special ICs for rotary encoder and your eyepiece. So I will put the camera overhead. So here we are. Before I undo the circuit board here, the plummet optical piece, there is a eye correction setting apparently. Focus setting of course, and this ring around will undo and will reveal what seems to be a precision adjustment to center the optical path of the lens with optics inside. We have the same thing in the other main optic here. So screws with holes on the side, you can put a tool in and turn them apparently. Interesting. We have a bunch of flat flex apparently going here, I believe, to the rotary encoder for vertical axis, because here we have the horizontal axis rotary encoder behind this circuit board, which is secured by 4 screws. So we have first shield, IC, neck, ESC03 and ESC04, I believe they are special ICs for rotary encoders. So obviously it will not be possible to, I will probably not undo the encoder because I believe anyways it will be stuck by a ball bearing and require a special tool to pull out. But we have here, you can see, oh, it is super delicate. We have pin header connections with flat flex to this board, you can see. Seems super delicate, so I will undo them. Try to. Okay. I did already write their numbers to be able to reinstall them in the correct order. Anyways, this device is not working, so it is not a big deal. But this seems quite delicate for an item that is prone to be moved around a lot. So here is your circuit board. Try to get you the best focus possible. Okay, nothing on the other side. we have here apparently the main optical pickup for the rotary encoder wheel, which is located in here. So I will undo this aluminum cover. It will reveal, yes, the rotary encoder wheel, as you can see. With these screws are super complicated because they have a fine slot, and if I want to undo them I need to modify an existing screwdriver. I do not have a Michelin screwdriver. And there is a screw in here, excuse me, okay. And what else? Again, it seems some kind of setting screws here in brass. You can see the super fine and quite dirty actually glass rotary encoder wheel. So with super fine stripes you cannot see by with naked eyes. And we have the optical pickup for it. I will try to undo this. So obviously here a light source at the other side, probably a LED. You can see we are getting serious here because we have Allen screws. Usually Allen screws means it is getting serious. Okay. Oh, it is weird. Wow. Look at this. This optic light sensors and photodiodes or something on this board directly onto the circuit board. 5 black rectangular things. I did never see something like this before. And we can see in the middle here the optical focusing for the encoder wheel. So everything in here is super high precision, obviously, and requires a lot of factory adjustment. And it is, I believe, all what we have in this side of the device. So probably the same setup in here, more or less. And you can see mounting screws for this, but I will not disturb it anymore. I believe it is enough already. But very, very beautiful optical setup here with these receivers for the encoder wheel. I am thinking if I can or not take a USB photo of this microscope photo, but because of the shape of my USB microscope it will be quite complicated, and I do not want to extract this part. It might be quite catastrophic, so I will put this back together. On the top here, after you undo 2 screws, you are able to lift this part, which is obviously covering the main bearing bracket securing the wall telescope assembly. So it is where you would proceed if you want to remove the middle piece, but I believe it will not be necessary. We will be able to have a good look at the both sides of it. So now let's go at the main electronics side. So this side is annoying because of the thing poking out here, so I have to improvise something like this. So you have your PTS 205 and serial number tag, and we have the main cover with 4 screws that are now magically off, and here is what we have. So in here nothing except the label for the reference to the settings. You can adjust stuff. quite mysterious, but I believe you will find the information in the user manual. So we have a nice circuit board with EEPROM obviously, one connector here, the connector to the power input. So actually when I receive this device, it looks like we had some leak here in this cartridge. There is no electrical connection to it, but there is a little tank here. Apparently, it is really weird. It is not a sensor because we have no connections, but it looks like it did leak more or less. You can see some oxidation here at the back. And actually the black wire here was completely destroyed. The insulation was burned, the copper was green and falling in parts, so I had to replace this wire. Luckily enough I found a matching contact and I was able to replace the contact also in the connector. But it is weird what happened here. So here we have our main circuit board that I will try to undo. I will proceed this way, it will be easier for me. So here it is weird because you have only two screws at this side, and here we have a header connector, but as you can see it is more or less loose, and in particular the ones here, they are prone to making bad contacts. So I was expecting to be the problem of the device, the bad contacts, but no. Maybe we have something else, maybe we have actually oxidation here because of a leak we had previously, and maybe this circuit board should require a bath of vinegar or something to clean. It is something I might try. So I have more flat flex to undo at the bottom, very gently, thanks. Two connectors here. Going to these parts, so here it will reveal the other rotary set of rotary contacts. The other assembly we have, like behind the control panel, you can see totally similar. One more circuit board with two ICs and wires going, I do not know where. Behind. There is something behind. But first on this circuit board here, we will have a better look at it. So here is what it looks like. The EEPROM we did read it and dump it, but there is nothing to see in particular in it. A lot of OK chips. So one of them must be a processor. And we have a plug-in board here that will come off with what seems to be an analog front end for something. Is it written? Asahi Precision, the mother company of Pentax, but nothing else in particular about what it does, this board. So here again you have pin headers that can make bad contacts in such an rough environment. So I will try to investigate. Here and here we have a lot of stuff going on. So here just the rotary contacts to the main telescope part, as you can see. And we have what seems to be, yes, optical path actually. Can you see here? This is a prism, this. So it is doing an optical path with the other side here. So I do not know if it will reveal anything useful if I undo this circuit board. Not much actually, but yes, precision adjustments here for some optical things. So I did lie, this is a kind of sensor, and I can see there is still, can you see it here? There is still a little bit of liquid in here. So it must be an horizontality sensor with liquid. And there is a whole optical setup here to read it. What seems to be actually, let's, or maybe no, no. Here we have what seems to be almost a laser diode. Little golden or brass package with a lens. Seems to, or OLED at least, with a collimator of some kind. And here, okay. These screws are completely stuck. I will try with a stronger screwdriver, but if they do not collaborate, I will not try any further. Which one? This one maybe? No, too thick already. So these Japanese screws can be annoying. No, because my tools will actually not fit correctly in them. Quite weird and annoying, but yes, we had a leak in this area. It did a leak over the circuit board. Ah, here we are. Sorry for the focus loss while I am doing this. We are not losing a lot anyways. Okay, we have all this for this black area of mysterious stuff, probably infrared filter here. So it did not reveal anything useful. Interesting. I will take the opportunity I am in here to try at least the over assembly. It is even more stuck. Okay, so I believe for this side of the device it will be all, except I have to mention I keep reconnecting this piece of flat flex and it keeps poking out. It is really not well secured and really should be a problem. So I believe in fact when the circuit board is in place, maybe it is pressing on it and securing it a little bit, but still quite weird and bad in a device you are moving around. Really not impressed here. There is not even a piece of tape or a piece of foam to secure it positively, or hot glue. I should even prefer hot glue. There's nothing here. Quite weird. Okay, so I will put back this wall side together and then we will be able to have a look at the main telescope assembly. So before I undo the two big covers, here a quick look under this panel. Actually we have what seems to be the adjustment, the center adjustment for the main eyepiece with again these 4 screws with holes on the side. So very precise adjustment. I see a lot of brass also in here. For some reason this cover is just secured with 1 screw, which is a little bit weird. Okay, now I will undo 8 screws and we will reveal at least what we have in this main area. One thing, there is a little access panel here on the side I will, I guess, not be able to remove, and also we have one here at the bottom in front of this, or behind, more exactly, this vial. We have one more access panel, but completely unreachable. Okay, but for this ones here, at least, it is just a matter of undoing the screws on the side. So I will do it right now and I will be right back. So, first cover to come off, this one, and we have one large circuit board with again a lot of flat flex connections. And I see, you know what? I see really particular stuff in here. Super interesting. So what to do first? Do I first disassemble this part here and investigate, and then we will go to the other side? Because you know what? I see things that looks like optical fibers. This is super fascinating. I will see if I can undo all this stuff. As you can see, we have a number of flat flex connections everywhere that seem to be super delicate. So I do not like this design of flat flex with pin headers, because it is delicate and really seem not to be well secured in their sockets. You can see, very easy to undo them. I am not impressed here. So apparently we have 4 screws, maybe just 2 to undo for this side of the device. I do not know how far I will be able to get in the middle piece, because I did shine a light inside and there is not much to see. In fact, there is a thing poking out in the middle like a little mirror piece, but it is all. Okay, what do we have? This circuit board is coming off, and we have what seems to be a lot more of super high precision stuff. As you can see, seems I need to undo. Excuse me 1 second. To find the correct screwdriver for it. 2 super small, actually. I will not need to get the high precision screwdriver box for it, and it is too small, of course. So you have all flavors of screws in this thing. You have Phillips, well, Japanese Phillips, CIS more exactly. You have slotted, you have Allen. Okay, what is going on here? Okay, box with, you know what? It looks like it will require some unsoldering. Here, circuit board going through the eyepiece to the other side, so interconnecting the 2 halves, it seems. What else? I need to refocus a little bit here. Super nice brass piece here, and this wall assembly seems it is a matter of undoing 4 screws. So I am considering if this box here is necessary to open or not. It should not be complicated, so you know what? I will heat the soldering iron while I undo this part. Soldering iron is heating, so I can try eventually to unscrew with the same tool I had previously, by the way, for the other difficult screw. This assembly, yes, really looks like optical fibers. So I do not know how the telemeter part works exactly, if it is laser or not, because we have not any laser warning sign on this thing, which seems quite weird. Well, if you have no laser it is normal, but usually telemeters need lasers. Will it come off? I have no idea. I did probe a little bit before the video the inside, but not so far. Okay. It looks like we are more or less good. Wow. That is nice. I have no idea what we are speaking about here, but really, guys, look at this. Seems to be expensive and complicated. Looks like we have here, yes, a little rotating piece, rotary filter or something, rotary shutter, with this apparently micro tiny 3-phase motor. It is what, maybe 5 millimeters in diameter, maybe less. Two optical fibers obviously going in here, another similar assembly here. I will not take apart this further, I believe, because as you can see it is just made of insane. And in here we have optical goodness prism going into this, so it is most probably the telemeter pickup here. Oops, that was not good. Okay, I will retrieve it later, but quite amazing. It is here the part I was speaking about. Will you see it? In here you can see it through the lens here, this thing. Maybe it is a mirror, just in the center of the optical piece of the lens. So we have more precision adjustment screws here with holes on the sides, as you can see. And everything in here is just terribly complicated and obscure. Okay, I will try to retrieve the washer I lost, and I will unsolder the cover on the circuit board. Okay, I was able to unsolder the piece of shielding, and here is what we have. Some kind of crystal oscillator, it seems, in a can. And these parts. Is it a laser power supply? Do you think it can be a laser power supply? Given we have no clue of what is this box. Toko. So maybe a DC to DC converter, maybe. Or something like this. So it might be power supply for a laser. Interesting. So I will re-solder this, reinstall all the mess in this side, and we will go to the other side hopefully. So, some tedious reassembly later, we are ready for the last side of the telescope piece. And are you ready? Ta-da! More electronics, obviously. A lot more electronics, which I try to get in perfect focus. The other sides of optical fibers I can see, and probably their sources or the receivers. So it would be interesting. Let's try to undo this circuit board. Very strong screw here, never undone before. Okay, we should lift out, I believe. Oh. We have some hot glue here. They did use some hot glue. And okay, it is apparently made in two separate parts. Probably one receiver and one transmitter. With your optical fiber connection here. I can see under the shielding 2 or 3 big ceramic capacitors, one IC, and it is all. And it looks like we have this ring that will come off and unmate the optical fiber like this. Yes, and here we have either the receiver or transmitter for the optical fiber, but I do not see how to undo it properly. Maybe I have 2 screws here and 2 screws here. So do you believe it is possible to do something with the screws? I will try. I am still connected here with this PCB, by the way. That is just coming out like this. It will be much easier without everything in the way. Okay. So actually I did try to remove the 4 screws, but it is not moving at all. There is a bunch of super tiny set screws and very deep, and I believe I was not able to find a correct tool for them, so no luck here, but it seems to be the receiver side because the other side is bigger. So one overview at the electronics here. Test point in the middle. Very nice ceramic capacitors with what seems to be gold terminals. Okay, we will have a look at the other part. So here again there is a ring I believe unscrew to remove the optical fiber. Not that easy, but it should come eventually. Excuse me, I was not expecting this to be so hard. The other one was loose, by the way. Maybe it is coming. There is a red sticker on this one. Maybe red as a red laser or red as danger. Not sure. Ah, okay, we are good. So one connector here to undo, and apparently should be possible to lift this one PCB. So this is the board coming from the other side with contacts between the two parts. Maybe we will reveal more optical goodness at the same time. One hidden screw here. That will be a pain to put back in place. Okay, of course, your annoying flat flex at the back with the pin headers. Oops. Okay, we are good. We are good. More stuff here. You can see the other side of this. We have here a little bit of a cover, and here one flat flex with LED symbol. Maybe it is your reticle illumination LED. What do we have in here? Yes, one tiny LED, but for some reason they did paint the end of it in black. Okay, so must be the reticle light, most probably. You can see how they did route the cables and optical fibers here, and actually secure them with some sticky tape. And I just lost the screw. Okay, I will deal with it later. Nice brass bracket here to secure actually the board for the little push button. But let's have a look at the main circuit board here. So here seems we have crystal oscillator, this ESC01 chip. We have a whole collection now, and this assembly, which is apparently secured by 2 screws and will be possible to disconnect. 78005 here. Is it a 0.5 volt regulator? Two screws are off, and yes, it is coming off. This part is heavy, so let me unsolder this shielding and I will be right back. So, shielding removed, we have this setup and access to one screw which I hope will allow us to have a look in here. I need a super micro Allen here. In fact, for this teardown I needed almost all of my precision tools. Do I have my super micro Allen screws? Yes, this one is working, so maybe I will be able to undo this cover at least. Some kind of collimating loss, it seems. So I am expecting to find a laser diode in here, but you have one on each side. Either way, I am perfectly ruining everything here, and you know what? I cannot go any further because my super micro Allen 0.035 is not long enough. Interesting. Let me check if I have not another one. So, Allen screws are amazing because no matter how many you have of the keys, how many expensive sets of weird sizes you did purchase, expecting to have all the possible size. No, I have not the correct one for this particular one. I have one, but not long enough. So it is quite a failure here. I will not be able to have a look at what we have in here, but we can expect a laser diode by the way. And I guess this will be the end of this video, because we did have a look at everything. A little bit sad I was not able to show you the laser things here, but their super micro tiny allen screws are annoying and too deep. So this will conclude this video. I will try to put all of this back together again. It will be tedious, and this item will go in my collection. Oh, this is quite dirty. This I will probably clean it with a magic eraser. But well, here we are. Super nice piece of equipment. If I have opportunity to find another one of another brand at the same range of price, I will do it, and it will be a nice comparison teardown, I believe. But this is super nicely made. Look at all this brass, unexpected optical fibers. Probably some more secrets down in here, but obviously I do not want to go so far in the teardown. It is already a lot of tedious works, you can trust me. So I hope you did enjoy this. So stay tuned for more videos, of course. Do not forget to share, subscribe, comment, and click the like button. Thanks for watching. Bye bye.